Okay. So I'm going to talk to you about an AIRRA allocation and what we did with it. And hopefully that gives you guys ideas of applying for some and then doing more with it. This work is part of the AI Institute for Resilient Agriculture. It's funded by NSF and USDA, mainly USDA. I'm also at the University of Arizona. Cyverse is one of my projects that is using it. And since I met quite a few Jetstream people, I'm going to put some Jetstream plugs also. I'm the co-PI on it. And I retire next week, so technically I won't be involved with any of these projects from next week. So ask me any question. I'll just give you emails of people who'll answer them. So I decided to break this up in two parts, sort of talk a little bit about AIRRA as a project, and especially when you want to get involved in agriculture, which is an amazing sort of area where AI applications are badly needed. And then how we started building a foundation model and why we built one, because it's a lot of work. And for most people, it's like, why the world are you, that's a solved problem. And in reality, it's not a solved problem. It's solved for certain sections of the world. And then NSF, NAIRE, and how it played the most important role in making us ready to do this. Otherwise, it was not feasible. And that has opened up a whole other class of solutions that we have created. And then how do you go from a concept to field deployment? There's a lot that is to be done, and I'll try and touch upon those. And then the second part is sort of deriving maximum value from your AIRRA allocation. I did not know that I was going through a sort of a test when NVIDIA started asking questions of what we could and could not do before they selected us for the project. And I want to share that with you guys. So even though NVIDIA is not active in the next round, this is what industry is looking for, and the scale that we want typically comes from industry. I'm hoping it'll also come from NSF resources. And then building your own AI toolbox, because I see this as like essential things that every student or faculty or a lab should have as a culture of what is your AI toolbox. And the last thing, which I'm extremely passionate about, is AI community of practice. Just like what you're attending today, if you don't have a community of practice in your home institution, in your department, a lot of the knowledge that you have disappears very quickly because tooling with AI has like a half-life of less than 6 months. And so if you know something, tell someone what you solved. Otherwise, everybody's banging their head against the wall. So I'm going to talk of these few things. I really like this third law of Clarke, which is any sufficiently advanced technology is indistinguishable from magic. And so for the rest of the world, we are producing magic when we are working through AI. And so you can call yourself magicians sooner or later. What do I do, or what have I done for the last 30 years? I would say most of my work is trying to bring what is advanced technology that's not completely ready to people that can use it, and then reduce the friction at the boundary of technology and adoption. So that sort of is my specialty. So any missing middleware, we are happy to write it so that the adoption happens, and then train people in using those technologies. And so end of the day, all I'm looking for is allowing my users to find the needle in the haystack. And this definitely looks like an Aggie guy, and a lot of my work is used in agriculture also. I prefer to use the word augmented intelligence because AI really makes people think that you are ready to do the magic. And those of you who actually work in AI know that that magic doesn't happen that easily. And so augmented intelligence sort of lowers the temperature, and I don't mean the LLM temperature, but I mean people's expectations from what you're doing and what you can deliver to them, and then find the features that are really important and emphasize on them. So this whole AGI business to me is nonsense because it's taking away the oxygen from all the real good things that are happening, and people are focusing on things that are out there but are not really useful today. And we don't have to imagine what they'll do. So there's an amazing amount of work that's happening. So augmented intelligence is a good way to look at it. So AIRRA, as the AI Institute for Resilient Agriculture, we are structured in the form of moonshot projects. You can see 5 of them, and I'm going to specifically talk about AI agents for pest ID and then the mitigation strategy. I'm not going to talk of all the other ones today. And so the AI-driven tools, we take the data and information we have and put all of that together so that it's an AI-driven solution that you can sort of start using. And we also explore a lot of foundation questions in AI, and I'll give you examples of boundary cases and edge cases in agriculture, which sort of drove us to do what we did. And then we provide the tools and products of value to the agricultural stakeholders, the growers, the breeders, and consumers. So our goal is to produce something that helps a community. And one of the reasons we did the foundation model was we were seeing large ag companies that had the data produce the models but not give anything to the community, and the startups were suffering because none of them could build some of the things that were needed for this. And then finally, sort of working towards these moonshots has been our focus. Our team, you can see the multiple institutions that are involved, and then you can see where our stakeholders are. A lot of our work is focused around crops that are in Iowa, Nebraska, but then we also focus on sort of small farms where the automation doesn't exist, but people want to do it, they don't have the money, and what is that minimal censoring that they need to do to create some of the digital twins that they're trying to build. So what does AI-powered innovation sort of look like? Pests are real loss. It's a rising risk. And in the US, about 10 to 35% of the crop often goes to waste because of this. And why are we doing it now? Because with all the changes that are happening, whether it's a change in climate, people are seeing new pests. Even as things get shipped, like in our case, we are working with groups in Taiwan where they import a lot, and they're seeing insects that their group has never seen before, and they don't know how to mitigate it. And the best thing they can do is reject the whole consignment, which is a lot of money also. And so how do you make it easy where the farmers that are working can mitigate something, they can reduce the chemical usage, because when they see something, they just want to spray a lot, which is not good. And because they haven't seen it, they're going to take a broad spectrum chemical and try and just take out everything, which is also not a good thing. And so pests are a challenge, and then you start getting weeds, and then the weeds become more and more resilient to chemicals, so you put more chemicals, and so it's like a vicious cycle, and then the disease come along and then take everything out. And so when you put all of this together, it is a fairly challenging situation, and there aren't many people that can just look at it and say, this is the direction you need to go, or this is what you need to do. So why is this a tough problem? There's a lot of variation in species, and you can see the same species look different depending on which region it is in. And then, different insects exhibit very similar color and patterns. If you're going after patterns and you count the patterns, these two things look very close, but they're different. And then you have multiple insects and stage per class, and they all look different in their life stage. So when it's like a caterpillar looking thing, and then when it's a butterfly, that's a big difference. But what do you call it when it's halfway in between? And so the detection with overlapping objects, like when you start seeing things where there are 10 insects piled up on each other, but there's one insect that's the pest that's in between them, how do you segment that and identify it? So there are several challenges that are large number of classes. There's fine-grained classification. There's data imbalance. Think of it like people love to take photos of butterflies, cockroaches, not as much. So you start getting all these things that are challenging. And then you need the robust classification, because if you're going to have them use a chemical, you better be sure that it's the right one. And then there's a lot of camouflaging, and insects are amazing. They adapt to the region, the temperature, the weather. So it is important to figure that out. And so our hypothesis was a vision, like pre-trained model using large unlabeled data sets can serve as a foundation model for subsequent fine-tuning with limited data set. And by this, what I mean is curation, human curation is the most expensive thing. And agreed, AI can do a lot of curation and help us now, but that AI is trained on something that human beings have helped. And in these cases, you want the human being to be at the sort of lead of it. And so if you start looking at this is again from Isaac Newton, I've seen further, it is by standing on the shoulders of giants. And I'm going to talk about the giants that have allowed us to do what we have done in our project. How many of you have heard of iNaturalist? Okay, a few of you, those of you who haven't, do go home and take a look. There are literally millions of data sets, or, from weeds to insects to animals, and they're organized and curated in ways that you would not imagine. They have licensing that allows you to do research with it. And so they have put amazing things together. And so citizen science is at the heart of what we can do. You heard from the prior speaker, like you can do things, and if you generate that data in that project, I'm taking a wild guess, there'll be some requirement to share it with the community. NSF encourages that, and I'm grateful for how that's come together. So you have people who are gathering data, organizing it, and then researchers who know what is what. Two of them, if they agree, it becomes research grade. If it meets the metadata level, it's ready for you to use. And this literally began as a student project. It was a student project and is now the world's largest biodiversity platform. And it's millions of people using it every day. And they're contributing critical data that I cannot imagine doing a project without something like this. So if data is the new oil, AI is the ultimate refinery. And so you can transform this data into useful things, and we also know refineries, what they do in terms of pollution, and I think AI has its own challenges that need to be addressed. So the foundation vision model for agriculture, so it was self-supervised learning. We went through data acquisition from multiple sources, so it's about 100 terabytes that we brought together. The citizen science data repositories, about 230 million images, and then we whittled it down to about 42 million, and I won't go into the details of what we did, but finally our data set was released as part of Biotrove through our work, and it's published through NeurIPS, and it got spotlight for it. So what changed for the citizen science projects? And I want you guys to be cognizant of the challenges of providing data. All the companies that are doing AI work right now are literally destroying citizen science infrastructure. By that, what I mean is they do denial of service attack every day. The moment they find you have a data set, because they are done getting the data that was easy to get. Now it's going after university libraries. It's going after your science data that's sitting in your lab on your website. They will come and crawl the heck out of it and take your servers down. So those of you wondering why this happens to you, when you look at your logs, you'll realize, and they do not respect any of the do not crawl parts either. But for citizen science projects, that meant a big deal. If you want to go to iNaturalist, or you heard about GBIF, GBIF doesn't keep its own data. GBIF has metadata and says, oh, this museum has this species, this museum has that. So when you say, I want this data, they'll give you URLs that you have to go collect from. And most of us are not capable of having crawlers that are going to respect the bandwidth capabilities of a museum in some remote corner of the world in Africa. But they have the rarest of rare image of some animal that you're trying to study. And so it's really important to be mindful. And so I'm really grateful that the foundations that have supported this over the years and taking a student project to millions and millions of and terabytes of images. But it was when these guys moved to Amazon and they were part of the Amazon open data sets. So now you can go pull terabytes of data in literally few hours that you could not do before. And so you're now getting these awesome data sets that you're not paying for. If this was locked down by Amazon as part of S3, like many of our governmental data sets, they switch them to downloader pays, and you have to get a URL. It literally becomes hundreds of thousands of dollars when you want to replicate that data set. So unless some VC is funding your research, which I hope they are, it's really impossible for a research lab to afford that. And so many of the citizen science projects were adopted by Amazon because there are other AI companies that are willing to take a snapshot of it and pay the money so that the researchers like us can get data from it. So the dataset curation and training of the large vision model. So Biotrove is the AI-ready data set We have about 136 million images. The languages it supports is Latin and English, Latin mainly because of the species names and others. So in 2024, that was our spotlight paper, and it was around 60 terabytes of data. But to build the models, the compute resources came from our NVIDIA and NAIRRA allocation. So we got 8 nodes of 8-way A100s on NVIDIA DGX Cloud for 4 weeks. We ran the VTB model, and it was about 50,000 GPU hours. We could not get that anywhere else in the NSF ecosystem or our campus ecosystems. And so it was, we are very grateful to have that support, and I'm glad that we have NAIRRA and Access and NSF. And so once we built it, we started putting this out as web interfaces people can use, but more importantly, we were starting to sort of get the trustworthiness where you can say, I don't know what this is. And if you don't know what it is, you sort of, when you do out of band or distribution, you can still give a good answer. And so here are some of the examples, but I won't go through it. And then I'm sorry to make you guys dizzy, but you can see that the robot is now tracking and following and detecting. And then this is then passed on to a system which then gives a full understanding of what it is. And then if the sprayer has to spray it, it also knows how to target that. And I have other videos for it, but we don't have to go through that. The integrating with LLMs, where you can then start asking these questions where, hey, I want to know more about this, and we decided we would support everything from GPT-4, Claude, Llama, and so that the data sets that we brought together, because every state has a ag extension specialist who are writing monthly notes on various topics that matter to the ag community there, whether you're a rancher, farmer, but those are written for like somebody that understands that. A rancher usually is not going to fully appreciate it, so they expect the ag extension faculty to translate that for them. And the LLMs do an amazing job of simplifying it, but then correlating things to it. But we also realized that we were dealing with things like old data that is PDF sitting on a university server, and when they make a copy of it, the date, modified date changes, and that's our logic. But it's from 5 years ago, and nobody uses that method. And so the information about the chemicals that we are telling them to use, or the pesticides, are almost like not available or banned in some parts. And so understanding what information can you give a person and assessing that was a challenge to itself. And so we wanted to bring in a lot more reasoning into it. And so here are sort of the examples where, is this harmful for my crops? Give me the answer, give me the citations. And so these are the kind of pipelines that you heard many of the speakers talk about. So then how do you navigate and scale with Access, NAIRRA, and Campus HPC? And I want to talk a little bit about that, because there is no one that's going to give you everything. NVIDIA just said, yes, DGX Cloud, going to give you a lot of GPUs, get your job done. And we're like, hey, we need an inference endpoint. We have all the things. Can we have ability to run that? Oh, that's not our problem. And I'm grateful to what NVIDIA gave us, but end of the day, for this to be useful for the community, there were other things that we had to build, which we are capable of building, but we didn't have the GPU resources to keep that up and running for someone when it's used occasionally. And so I'll talk about how we sort of blended everything that we could get our hands on, and I think that's the mindset each of you need to have, and if you already don't have that, is that if somebody tells you, I'll give you everything, be very careful as to why they're telling you that, because most likely there's something else that will be a exclamation mark, or I'm sorry, a little mark somewhere which will say, hey, you have to also do this, this, this to get access to it. So you pretty much have to build your stack solution of how you want to bring AI to the community that you are building. Because if your job is to give it to someone, if you don't have inference endpoints, you are stuck in a few different ways. So I'll talk a little bit about managing data, because that was the biggest challenge at the starting point, because we wanted to launch about 5 different campaigns. And then once the data was coming together, we had to figure out how are we going to keep our data products in sync. Because when you start talking of millions of files, hundreds of terabytes of data, and not one place where this data sits, what is your distributed data handling capabilities? How are you going to make sure you are not hitting the same data source multiple times? And so we built something called FlowDC, which is sort of flexible, large-scale, orchestrated workflow for data collection. And you're going to hear about workflow engines and managers when Mats and Karan talk about Pegasus. If you don't have a tool like that in your pipeline, doing scalable work is nearly impossible. You will end up repeating yourself and not keeping track of where your data is, or every time you have to update the data, you're going to try and get it again and again, and you will not finish what you have to do because there are sources that will be down, not available, and then you forget that they were down last time you tried. So this allows us to sort of use a much more hands-off approach. And we looked at so many different systems, and we finally sort of settled on Taskwine. How many of you have heard of Taskwine? Okay, the regular crowd does. Those of you who haven't, this comes from Doug Thane's lab, and I highly recommend you look at it as one of the solutions for keeping track of tasks that are running on HPC, that are running on commercial cloud, that are running on wherever, and then have a coordinator that manages it for you, and it can scale out really well. And so what we did is generalize this in ways where you just launched workers, and they dial back home, take a task, do things, whether it has to pull data from somewhere, label it, compress all of it together, convert it into a file format that is friendly for PyTorch to read, apply the metadata from Croissant, so we were not touching data that we were not supposed to, even though it was part of the data set, and I'll talk a little bit more about it. And so FlowDC, I would say, allowed us to create a policy-aware data downloader, where we could say, if you're pulling data from a server that you feel is getting stressed because you're now asking for data very quickly, how do you back off? How long do you wait? And then you don't wait too long to realize that it wasn't them, it was you, because the hard disk that you were writing to on your server was slow, and hence you were seeing the distress. And so these policy-based systems are really helpful. And so we ended up, the total time we took, like in 3 hours, we could bring in many terabytes of data from Amazon, and we trained multiple models. So we have WeedNet, InsectNet, AIRRAnet is another one that we are working on. And so this campaign, once it's done and you have the data every month, there's new data, and we keep track of it, and then we look at the threshold of when do we build new models with it. And so now I'll sort of start wrapping up on sort of what I would call the AI digital divide. People who have access to GPU and people who don't, people who do machine learning operations and people who don't. And so the AI workbench, as I was telling earlier, you almost have to have a standard for your lab where you say, here's my interactive environment, here's my Jupyter lab, here's my Colab, here's my coding environment, here's my data set where I get them from, here's my data management tools, and I've given the names, so I'm not going to go through that. But the compute resources that scaled from your laptop onto your campus cluster, onto NSF cloud, and how do you do that? And I would say the most important part is experiment tracking. How many of you track your AI experiments with MLflow or Trackio? Okay, I see one hand go up. Please do, because if you are going to be doing some of these things, Trackio is sort of from Hugging Face. It's much lightweight. And then you need access to inference endpoints, whether it's a frontier model or your custom, and I'll give you some examples of where you can set that up and where we use it. And then quick, rapid prototyping of front ends so that people can assess what you've built. And then be prepared to opportunistically use anything that you can get your hands on. Even though we were an AI institute coming from multiple groups where we had GPU access and whatnot, we were like, the moment somebody said, oh, I have a new cluster and somebody needs to burn hours on it, we were there and we would use it because our data and code was organized. We were not waiting for how will we get there. And by the way, that was one of the trick questions the NVIDIA people asked. They're like, okay, we'll put you onto the system. In how many hours will you start training your model? And we said less than 8 hours. They're like, okay, we'll give it to you. Because if they are giving you that many GPUs and you're going to spend 1 week downloading your data, they're not going to choose you. So a few additional tools that you really need to know about. You heard about Claude, and so some sort of coding agent that you have access to. Large language models, API keys with some ability to run inference. And then MCP, again, I'm not going to go into it because you heard quite a bit about it, but all our data has the MCP protocol capabilities of talking, so the agents can talk to our data sets very nicely. And then the sandboxes, you don't want the AI agents working on your desktop or your laptop, and then I don't know how many of you suffer from this, but at some point you get tired saying, okay, you can access this file, okay, you can make this edit. Then you'll be like, okay to everything, and then you realize you like set yourself up for some dangerous things. The automation is central to it. If you don't have automation in what you're doing, and by that what I mean is things that are going to do the work for you, and I don't mean agents, like things that you can control and you've written, and if your repository is not on GitHub and you don't track your changes and then you're trying to do something, it's hard. And then the most important part is somebody that can assess the security and risk for your sandboxes, so as you start getting more into the AI pieces. And then for that, I want to sort of talk about Kaka, which is available on Jetstream for all of you, and I added this slide this afternoon so that you get a sense of how do you take infrastructure as code so that what you need, you're not setting that up one by one, but this has, how many of you know what Ansible is and Terraform? Okay, so this allows you to write a recipe for deploying your infrastructure. And so take a look at it. There are quite a few templates we already have, and it gives you a nice web interface, but anything from connecting Colab to a GPU in Jupyter, you can do that. No need to give money to Google. And whether you want your own Slurm cluster, you can use Magic Castle. And the last one, Bag of Words, since many of you talked of agentic analysis platforms, take a look at this. It's a really nice platform to do agentic work. And then sort of towards the end, I would say the community of practice. How many of you know Car Talk? The gray hairs in the room will know it. So yeah, click and clack, right? And so people would call and say, hey, I have this car, it's making this crazy sound, and it does this. We need that for AI, where you say, I'm trying to build this model, it's doing this, I saw this, and then you have the click and clacks of AI. So hopefully some of you will become click and clacks of AI. And so you want to share your innovation in many different ways. And what I would say is, please support your colleagues and projects that are providing you open source resources and infrastructure, because it's really hard to run projects, whether it's Pegasus or it's Sage. If you're not going to use it and talk about it and utilize it for your research and write about it, it's very hard to keep doing some of these things. So please find a way to support that. And I'll end by saying, this is the African proverb that has driven all my work, which is if you want to go fast, you go alone, and if you want to go far, you go together. And I strongly believe in going far together, so thank you for being with me here.